We talk about conservation of mass now, and in the same tone, we have already defined them. We have shown and indicated how the terms will be used and shown. We have already mentioned an example of mixing of gases within the closed system. So here is another example, and also trying to show how energy is related to the mass using the Einstein's equation, and the value of C has been indicated here as well. So I don't talk much about it. Instead, we need to develop the equations, and therefore we try to move in that direction. And the mass flow rate, the amount of mass flowing through a cross section per unit time. So in our calculus, as you know, if we want to calculate something, we start calculating it by a small variation, and that sometimes we call it infinitesimal variation or a small derivation, and we denote it by different Greek alphabets, and in this case it is delta m dot. So m dot is the rate of change of mass, as we have seen already, and delta is the familiar Greek alphabets. It's only showing a small change in rate of change of mass flow. So showing how the mass is flowing. So this is, as we have described above, it's showing the differential mass flow rate, and it's a small infinitesimal variation. It has been trying to show through this picture also that you are seeing. If we consider an arbitrary surface on which the fluid is flowing, then you see, let's say, a small area that is being considered, and in the surface we considered it as a curve. So on a curve we cannot draw a perpendicular, so we take a vector that is perpendicular, that is in the vertical direction to the surface, and as the surface moves, that perpendicular vector remains perpendicular at each point. We sometimes call it the unit vector that is normal to the surface. So that's the terminology that we use, and that is used by n. So here n is that vector shown by the head on top of this, and then the v is the velocity vector with its components has been shown, and the total controlled surface is drawn by red line. So obviously mass is equal to rho. Rho is, what is rho? Mass per unit volume. So if we have to calculate the total mass, then that will be rho, which is unit volume, into the volume Vn times dAc. So because volume will be calculated by multiplying the area into the height. There are three-dimensional when we are talking about the volume. So therefore, if A is representing the area, then Vn is a normal quantity, and we multiply with that also within the controlled surface to obtain the volume. So delta M, total mass, will be density times these other quantities that are being shown here. And in terms of point functions, we have already mentioned that the Vn is the normal velocity vector on the surface. A special alphabet has been used for it because it's drawn, it's not a on a rectangular coordinate, it's a vector that is being considered along a surface that is continuously changing shape. So point functions have exact differentials, and therefore integral from lower limit to upper limit, one point to the other point, over an area shown by AC will be equal to AC2, that is the integral at upper limit minus the integral at lower limit. So what I want to say is that this integral will be equal to A from the limit C1 to C2. And therefore these are the values that we will be obtained. They will be equal to this, where R is the corresponding radius, and therefore we will have these values coming in for us. And then the other terms that we shall be using in this discussion is average velocity. So the average velocity will be considered as this much. It's the quantity that we obtained earlier, and if we divide it by the whole area that is under consideration within the control volume, then that will be termed as average velocity. And since the surface is changing, the area may be changing, we need to integrate it within the limits, and therefore it's shown as in the integral form. The mass flow rate, of course, is given to you already in whatever units that are under consideration. Mass is equal to rho into the velocity, which can also be written as V dot over nu, and similarly these values, these equivalent values that are being used, and we shall be using them from time to time.